Hello, my name is Michael. I'll be talking about the canned gossip function. You'll see that it's on Outlook because I don't have OBS for Linux, so I emailed to myself and I'm using it so that way I can look at my Windows operating system. So yeah, anytime we're talking about debugs, or if debug's mentioned, we're going to ignore it because debug is for if the program's going haywire to figure out why, but we're going to assume that the program works perfectly fine, which I got it to work perfectly fine, so we can ignore the debugs. It's outside of the scope, because then I would have to start talking about debug functions themselves. So, yeah. So we'll start off with our kind of function definition. So it's a bool. So we're seeing if there's a path from start gossiper to end gossiper. If there is, return true. If there isn't, return false. Uh, and then yeah, that's the only thing to talk about with the definition. We create a stack called the gossiper path. This is our linked list that I had to implement. Um, but yep, it's called stack, or it's of stack called gossiper path. Gossiper path dot push. So this is putting at the top of the stack our start gossiper. You always want to do that because that's your starting position. So always want to put that in first before you even start doing anything else. You know. So now we have our for loop. The way how I looked this up, because I've never seen just like two semicolons like this. It basically, if we ignore this middle part here, let's say like we deleted it, this turns into this just basically then this four parentheses two semicolons aside just means while true. Um, so with this little extra statement in the middle though is basically a while statement. So it's saying while this is true, initiate this. So let's look at what actually has to be true for this loop to keep on going. Our first part, well, one, we have an and statement. So that means if this, ooh, I clicked. Okay, it's just now going to amazing. Okay, well that's going to be weird now. But so that means if this is 0 or if this is 0, then while loop ends. So we can look at them separately. So if our grasshopper or gossiper path dot size is 0 or is false, we want this to end. What that's basically saying is if we somehow didn't put in the start gossiper into our gossiper path, then we don't want to start looking through everything because we don't know our initial position. Uh, with that should never happen, given how the statement is right here. But this is just for some sort of weird case. We want to look at all edge cases. So somehow, if we created a path that had no starting point, well, that's a weird, like, that's not a true path. Path always has a start and an end. So we don't want to go through a loop. So that's what this statement is checking. Then we're looking at that the gossiper path dot peak is not equal or equivalent to end gossiper. So what that's saying is that if the top of our path is not equivalent to our end gossiper, we then want to keep on going. So this is you'll learn from this loop. We'll be constantly adding in destinations here. So eventually we want to check for cases where, let's say there's a case of where the start is also the end. Well, we don't want to create a path because our path is already created. We've already pushed in start gossiper, which in this case is also end gossiper. So we already have a path. No point trying to look at any other paths because we already have it. And then the other case we have where we are putting in additional paths into gossiper path. We're putting in these additional other gossip points. Uh, we then want to see if any of these points are the end gossip, because it is. We want to stop looking at other paths and end this loop. So that's what these conditions are looking for. So we have this little statement right here, which is basically which is taking just the top part of our stack. We're going to take the value of it. We're going to put it to this variable. Then we're going to take in our array of paths that can be that of or sorry. We're going to take in our array of possible gossip points. We're going to take whatever's on the top right here. We're going to set that it's already visited. This will be more explained later on, but we don't want to we don't want to keep on going visited past. We only want to go to a point that's visited once. But we'll look at that into further explanation. Actually, I'll just say right now. Basically, if you were to take a path all the way to the end of it and mark each one of those gossip points as visited, but you didn't get to the end destination, well, you don't want to take that path ever again because it's already been done and you know you can get to the end. So that's why we want to set. That's why every time we jump to one point to another point, we want to set that as visited. So that way, when we start backtracking, because we found a path that didn't take us to the end, we want to start backtracking, and that's how we're going to figure out if we want to go, how we're going to determine our new path to try and get to the end is by looking at points that we've already visited. Sorry if I keep on confusing points and paths. We'll start with P. So you might also hear me say grasshopper instead of gossiper. Yeah. So now what we're doing is we're creating an array of all possible neighbors to the top. Yeah, we're looking at all possible neighbors to that are neighboring our top point of our stack. So if we want to assume that so far that the top thing in our stack is just the start point. We won't look at anything. This statement right here is saying we want to look at anything. We want to figure out our neighbors. We want to. Sorry, did I say that was an array? That is not an array. My bad. That's neighbors of current grasshopper is not an array. That's my bad. But we want to know all our possible neighbors from our starting point. We want to know them so that way we can. But all of them that haven't been visited, we want to see potential next points we can get to. So that's what this statement is for. Then we want to check the size of the neighbor's grasshopper. This is so that if let's say there's no path to get from the start gossiper to the end gossiper. So we've tried every path possible, and there's just no path to get to the end gossiper. Well, after doing all of our backtracking everything, we're going to get to a point where we'll basically we will pop out, as you'll see later on, we will pop out our stock gossiper, and we'll have 0. We'll have nothing in the stack, because we couldn't find anything. We just kept taking out, when we backtracked it, we kept taking out previous points, gossip points, and so now we just have nothing. We have no neighbors that we visited, that we have not visited yet. So we have 0. 0 will then be false, which means we'll go to our else statement, which is then, as you'll see, will be our pop. So this would be, let's say A went to B, and then B went to D. B could then go to C or D, and C or D didn't go anywhere. And the endpoint we want to get to is Z. That's our end gossip. Well, we get to B, we go to C, find C has nothing, so the neighbors of current gossiper, the size will be 0. We want to pop that out. We go to B. We already visited D, so now there's nothing. So we wanna that's 0, so we want to pop that out and go to A, and then A is also happened to connect to Y. So then that's the new path we're going to do. So we go to Y, which turns out it's neighbors to something, and it's something we haven't visited yet. So now it's 1, so it's true. So our true statement is now gossiper.push. So basically we are taking the neighbors of our current gossiper, and it's basically just taking the first element inside of our neighbors. So the first element inside this neighbors, we're just going to, which in this case, yeah, we're going to take just the first one, the first neighbor that's connected. We're now just going to put that on top of our path. Now it's on top, it's on the front of the path. And then we go back. So let's say Y was neighbored to Z, right? So we checked Y, it did have a neighbor we haven't visited yet. So we put Y now, or we put Z
on top. Now we put Z in our stack. All right. Now Z is in the stack. So I guess I should have said, A connected to Y, A connects to B and Y. B is already visited, but Y hasn't, so we still have size of 1, which means now Y is on top of our stack. Y isn't the end, so this for loop still keeps going. And then we check and we see that Y connects to Z. We haven't gotten to Z yet, so now we put Z on top of our stack. And then in our for loop, we see that Z. We take the peek up. We look at the top of stack. Turns out that Z, which is also our end gossiper. So now they're equivalent. So now this for loop is false. So now we break out of it. We unset all the visited points, gossip points. This is just so that if we were to reinitiate this function again, everything's cleared, everything's good, just kind of some tidying up. So now we check, was a path actually possible? Because it's possible to break out of this loop. Remember, because it's possible to break out of this loop. The two conditions to break this loop we found a path, because we kept on making this stack until eventually the top part of the stack was equivalent to the end gossiper, or the size was 0 because we couldn't find any path. We just kept on taking off points until eventually we even took out the starting point, and then in that case ended the loop. So now we're checking, was a path found? Which there's two possibilities. We found a path, we didn't find a path. And so this is what this is checking right now. If every path that is possible will be a size of 1 or greater, and the end path, the top part of the path has to be the end of it, or the top point has to be the end point. So if that is true, then we want to say path found is true, because it's true. We found the path. But any path that could not be found will have a size of 0, then this will be set as false. And that's true. Never found a path, so it should be false. We go to this if statement, ignore the debug, which means we ignore the debug. We should really just ignore all this. Then we return our true-false statement here. So yeah, this is the explanation of the gossip function. Basically, it's just kind of going through. If I were to give it a quick summary, basically just it makes a stack, puts our stock gossip on there. It will then check for any condition that if the top of the stack is our end gossip, we want to end it and say that we found a path. If not, we want to keep on going, and then we're then checking any neighboring gossip points to see if they haven't been visited yet. If they haven't, we want to visit one of them, and then mark that we visited. We want to keep on repeating that, checking any unvisited and visiting one of them. Keep on repeating that till we find our end gossip. If we do find it, end the loop, because this is true. We found our path. If not, let's backtrack. We backtrack one element back, and then we want to check the unvisited. We keep on doing this backtrack, pop. We keep on doing this pop, push until we eventually find the right, kind of spider our way to the right path to get our end, to be able to connect our start gossip to our end gossip. Or we find nothing and our stack is 0 because we kept on popping everything and it was impossible to find a path. So yeah, hopefully that was a good explanation and nothing too convoluted. Yeah, thank you.